I'll go over a few examples that demonstrate the importance of links, covering topics that are of interest to many of our customers, including carcinogens, hydrates, EU hazard classifications, exposure limits, and transportation classifications. I'll close by providing some actual numbers of chemicals affected by generic entries in the ACGIH TLV booklet. Generic classes of chemicals are present in nearly every chemical regulation. Links in LALI help a user find all of the relevant regulatory information for a specific chemical when it's not explicitly listed in a chemical regulation. You don't have to go very far in the world of chemical regulations to find listings that include groups of chemicals rather than just specific chemicals. Look at the very beginning of the IARC Group 1 list of carcinogens. You see that this list includes agents and groups of agents. I've highlighted arsenic compounds, and at the bottom of the slide, you see beryllium compounds. It's not just beryllium that's considered to be an IARC Group 1 carcinogen, but all compounds that contain beryllium. To manage these generic listings, LALI has linked specific chemicals to the general listings. The first example will use the LALI query program to search for this specific chemical, beryllium dichloride tetrahydrate with CAS number 13466-27-8. Using the LALI query program, you enter the CAS number and make sure you have the Show Links box checked, and then hit the Add button. This very important screen shows that the LALI query program links beryllium dichloride tetrahydrate to its anhydrous material and to beryllium compounds. Check both boxes to include them in your search results. The only LALI lists that are direct hits for CAS number 13466-27-8 are 3 physical property lists. If the searcher stopped here, they would incorrectly conclude that no regulations impact beryllium dichloride tetrahydrate. This would be a very wrong conclusion. You must look at all the relevant generic listings to get the whole regulatory picture for your chemical. As Rachel already mentioned, we link hydrates to their anhydrous CAS numbers. We do this for several reasons. We do it to assist customers with determining the TSCA inventory status of a hydrate. Many country chemical inventories, like the U.S. TSCA inventory, do not list hydrates, but they consider a hydrate to be listed if its anhydrous version appears on the inventory. Another reason we do this linking is to help customers find tox data, hazard classifications, and other relevant chemical regulations. Expanding the display for the beryllium dichloride anhydrous CAS number shows that it appears on 6 inventories, and at the bottom of the screen, we see that beryllium dichloride is listed on the TSCA inventory, so the tetrahydrate would be considered to be listed as well. Another reason to link hydrates to their anhydrous chemical is that oftentimes there will be toxicity data for the anhydrous material. The molecular weights are different, of course, but the information is relevant. We see here that we have an oral LD50 in the rat for the anhydrous material. Most regulations that affect the anhydrous material will also impact the hydrated material. After all, we live on the water planet. So to effectively study the regulations impacting a hydrated material, you must look at the regulations that list the anhydrous chemical. For example, we see in this display the U.S. Clean Water Act information for beryllium dichloride would also apply to beryllium dichloride tetrahydrate. The link to beryllium compounds hits many lists. 3 examples are the IARC Group 1 list of carcinogens, the SARA 313 list of toxic chemicals, and the European regulation on the classification, labeling, and packaging of chemical substances. Because our compound of interest, beryllium dichloride tetrahydrate, is a beryllium compound, all hits found through this link are valid. This screen shows that beryllium compounds are on the IARC Group 1 carcinogen list and on the SARA 313, Section 313 list. This screen shows hits for beryllium compounds expanded under European Union legislation. To summarize then, for the beryllium dichloride tetrahydrate example, LALI without links found only 3 physical property lists. LALI with links found information on the anhydrous material and on the category of beryllium compounds. Specifically, these links led us to 3 very important pieces of information. That beryllium dichloride tetrahydrate is an IARC Group 1 carcinogen, is on the TSCA inventory, and has prescribed EU classification and labeling requirements. As a second example, let's assume you are using LALI to help in your hazard evaluation of this compound, cyclopentadienyl molybdenum tricarbonyl dimer. We would enter the CAS number into the query, make sure the Show Links box is checked, and the program identifies 2 possible links to molybdenum insoluble compounds and molybdenum compounds. We'll check them both so they will be included in our search results, and you can expand to see the listings for each of them. If you expand the search results for this specific CAS number, you would find that cyclopentadienyl molybdenum tricarbonyl dimer appears only on a REACH list and on the INEX inventory. There are many more listings for insoluble molybdenum compounds than there are for our specific chemical of interest. All the listings for insoluble molybdenum compounds are relevant for our specific chemical and are important to consider when writing a safety data sheet or evaluating the regulatory requirements. Exposure limits are only found with the link to molybdenum insoluble compounds. These exposure limits for molybdenum insoluble compounds would need to be displayed in Section 8 of your SDS for cyclopentadienyl molybdenum tricarbonyl dimer. I only expanded the lists for ACGIH in Italy in this example. The next screen shows molybdenum compounds. To complete your LALI evaluation of your specific dimer, you also want to look at regulations that list molybdenum compounds. You can expand or collapse views to find regulations and lists of interest to you. For example, expanding the jurisdictions where your company conducts business. In this screen, I've expanded hits for Thailand, Canada, and California. I have one more example regarding exposure limits for safety data sheets. The listing in the ACGIH TLV booklet looks like this for methyl cyclohexanol. This CAS number covers all the isomers of methyl cyclohexanol. Behind the scenes, Lally has 22 other CAS numbers linked to this general CAS number. For our example, we will search for the trans-2-methyl cyclohexanol isomer. This CAS number is not found in the actual TLV booklet, and therefore it will not appear as a direct hit on any ACGIH list in Lally. Lally wants to be true to the source and mimic what the actual list shows a reader. This screen shows values for the general CAS number that covers all the isomers, and we see that the TWA values display as they actually appear in the TLV booklet. For the actual specific isomer, the trans-2-methyl cyclohexanol, we see that ACGIH hits do not appear. You must use the link to the general CAS that covers all the isomers to get to the relevant exposure limits that you need to display on your safety data sheet. The last example deals with transportation lists like the DOT hazardous materials table shown here. Transportation regulations have many generic entries. Look 6 down on the list, we see amyl mercaptans. In this example, we'll search for CAS number 616-31-9 for pentane-3-thiol. The system identifies amyl mercaptans as a link. Remember from Rachel's slides that links are recommendations to the user for further investigation. Check the box by amyl mercaptans and then hit the search button. Then we'll hit the plus by our specific chemical to see what the Lally query program finds for our specific chemical. Pentane-3-thiol appears on these lists in Lally. We see a REACH list, a list from Denmark and Germany, a couple of inventories, and there's some physical properties. The next slide will show what shows up under amyl mercaptans. Here we see the DOT listings, and we also see IATA, IMDG, ICAO, ADR, ADN, etc. Without Lally links, you may have missed this connection, especially if you didn't have a flashpoint or chemical names using amyl or mercaptan. To close my section, I want to stress that links are important because chemical classes are important in the world of chemical regulations. Links are your computerized solution to dealing with chemical classes in chemical regulations. I gathered some numbers at a point in time to illustrate the huge numbers of chemicals impacted by links to chemical classes listed in the ACGIH TLV booklet. There are 724 specific CAS numbers in the TLV booklet. The shocker is that over 8,500 additional chemicals are included through links to the listed chemical classes. The next 5 slides show examples of generic listings found in the TLV booklet and how many specific chemicals are linked to them in Lally. For example, you see we have over 300 chemicals linked to antimony compounds, 95 chemicals linked to borate inorganic compounds, 178 chemicals linked to cobalt inorganic compounds. See that we have almost 300 chemicals linked to lead inorganic compounds, 243 inorganic manganese compounds, 345 chemicals linked to selenium compounds. And the list goes on, ending with 430 specific chemicals linked to the generic listing of zirconium compounds. Many of these chemical classes appear on a large number of regulatory lists. For example, cadmium compounds appears currently on 366 lists in the LALI database. When a new chemical containing cadmium is added to LALI, it's linked to cadmium compounds and effectively listed on all of these 366 lists. Jennifer Diley will now demo LALI Desktop and LALI Online.